production of Caesura Guided Tour is supported by viewers like you. Thank you. Welcome to the 8th episode of the Caesura Guided Tour. The Caesura Guided Tour is a series of videos where I build Caesura, an iTunes-inspired music player for Apple platforms, feature by feature. In this episode, I'll be going over some major architectural changes that I made to Caesura at the end of November as I adopted coordinators. Because of how drastic this change was on the code base, I think it would take forever and be really boring if I tried to explain changes individually. Instead, I want to explain what problems coordinators were made to fix, what Caesura-specific issues I wanted them to fix, and give you an overview of how the code has changed. Once I've gone through adopting coordinators, we'll look at two changes that went live with the release of Caesura 2021.12.17, namely being able to reopen the main window if you accidentally closed it, as well as fixing an issue with sorting by order in playlists with 10 or more tracks. Let's get started. Before we can get to coordinators proper, it's important to refresh our understanding of how Apple's UI frameworks are structured. AppKit on the Mac and UIKit on iOS use the model view controller architecture. This is composed of three main groupings of objects throughout your application. The model, which generally refers to the raw data fueling your application. The view, which is a means of presenting something visually on screen. And the controller, which sits between the model and the view. In theory, this should relay data from the model to the view that you're presenting on screen and handle mutations to the model data in response to user interaction. Now note that I say in theory because in practice, controllers very often end up being a junk drawer for all kinds of things that don't clearly fall into either the model or the view. This has led to the popularity of the phrase massive view controller, as more and more functionality finds itself embedded within controllers when they should probably be split into more distinct objects. Coordinators, also known as flow controllers, are one such object. Coordinators were popularized on iOS by Soroush Kanlu when he wrote about them for the first time in 2015. Coordinators ideally take over the initialization of your app's main window, handles transitions between different views and windows, and provides dependencies for underlying views. They can be a good first step into breaking massive view controllers into smaller, more focused objects, and removing strict dependencies between your logic and the controls used in your user interface. The way you can accomplish this is by using coordinators to provide a public API to the logic behind a given window or view that abstracts those implementation details away. Coordinators are definitely more popular on iOS than they are on the Mac. In fact, I've never really seen anyone discuss using them on the Mac, but it seemed like an idea that I was interested in adopting for the iOS version of Caesura eventually, and an adequate solution to problems I was currently experiencing on the Mac, so I decided to go ahead with it. So what was I hoping to fix with coordinators? Well, we've had some bugs creeping up due to things behaving inconsistently when windows are initialized in different ways. When the main window in Caesura is initialized by the app at launch due to being the designated starting window in the storyboard file, the end result is a window in a different starting state than if I initialize the same window manually in my code. A tangible example of this can be found in the Preferences window. If you changed the Caesura library file through the Preferences window and closed it, I wanted to make the app soft reset by closing the old main window and reopening a new one with the new library loaded instead. But when I did this, things weren't quite right and audio simply wouldn't play from the new library when a track was double-clicked. Tracking down each inconsistency within my windows sounded miserable, so my idea was to eliminate the inconsistency by no longer relying on two distinct ways of initializing the main window, and simply doing all window initialization manually through coordinator objects instead. This is also going to help me with things like the Preferences menu item. Previously, selecting the menu item would always instantiate a new window, and you could bring up a dozen Preferences window at once if you wanted to. The reason for this is I had no way to look up if a Preferences window was already opened by a previous use of the menu item. With coordinators, the app's primary coordinator can check if a child Preferences coordinator already exists. If it does, then that coordinator is holding onto a reference to that window, and we can simply focus the window instead of opening another one. Likewise, we can add a menu item that will reopen the main window if it's accidentally closed by the user, and use the same code path that's used at the launch of the application to do things in a completely consistent manner. The coordinators in Caesura form a loose hierarchy, and we need a root coordinator to sit at the top. That root coordinator is the Mac app coordinator, and it largely takes over responsibilities previously held by the app delegate class. This root coordinator essentially holds the dependencies and minimum logic necessary to make the application function while no windows are open, and handles spawning child coordinators which will themselves manage child windows. In our case, this means the main window and the Preferences window. The coordinator's initializer takes in a menu state handler argument. Menu state handler is a protocol which implements the set repeat mode menu item state and set shuffle mode menu item state methods. You'll see what these are used for in a little bit. Let's move on to the properties. First, we have our dependencies, a library service instance for interacting with the database, and a reference to the menu state handler object that I just mentioned. These are initialized at the root coordinator level and are propagated down to child coordinators as they're needed. Our root coordinator can also hang on to state that is relevant to our application when no windows are open. We have an optional reference to the collection player that will exist if something is actively being played back, and we have two properties for the repeat mode and the shuffle enabled status. Both of these use did set handlers, which automatically propagate the repeat mode and shuffle status to the collection player if it's already instantiated, as well as calls the corresponding menu state handler object so that the repeat mode and shuffle status are accurately represented in the user's menu bar at all times. Coordinators are primarily about managing flow and navigation between different parts of the app. The widely used pattern is to have a start method, which is called when a coordinator is first initialized, an end method, which is called when the coordinator is no longer needed, and then navigation methods that spawn child coordinators for other views and windows that we want to display. Here, the start method takes over much of the duties of the app delegate's old application did finish launching method implementation. Here it spins up our dependencies by finding the library file path, making sure the database is up to date with our latest migrations, initializes the library service dependency, and then spins up the main Windows coordinator. The end method does much the opposite. It winds down the coordinator so it can be properly disposed of. Here it does so by stopping playback, disposing of its library service instance, and then asking its child coordinators to clean up after themselves as well. Then we have the navigate to main window and navigate to preferences navigation methods. These check whether their corresponding child coordinators exist already. If they don't, a new one is initialized and their start method is called to present the window to the user. If the coordinator exists already, instead we call its focus window method, which simply makes that window come to the front. We also need counterparts of these methods for when the child windows are closed, so that we can dispose of their child coordinators when they're no longer needed. Main window closed merely empties out the main window coordinator property. Preferences window closed takes a boolean should soft reset argument, which reboots the root app coordinator so that it can load from the newly selected library path if it was changed by the user. The root coordinator also exposes a lot of methods that provide information from or otherwise interact with the underlying collection player instance for player management. Some are simple actions such as play, pause, stop, toggle, previous and next track. Others provide more granular playback status for specific collections or tracks. Importing tracks has also been moved here from the AppDelegate class. The AppDelegate class gives you a little taste of what to expect in other controllers we'll see throughout the rest of our video. Its responsibilities are much simpler now. They boil down to two things mainly. On the app's launch, initializing a Mac App Coordinator instance until it gets to start, and responding to menu bar item events and dispatching calls to the coordinator for their respective actions. You may remember that when we were initializing the main window via the storyboard, the window would be initialized and shown before the application did finish launching method was called. We needed to defer certain tasks until we got a notification confirming that the app had finished launching, and this would cause things to load in subtly different ways depending on when the window was initialized. None of this is an issue anymore because all of the initialization is happening within application did finish launching, and importantly, the entire process is now in our control. We can guarantee that our dependencies are there when we need them. This allows us to simplify our code and remove a lot of workarounds simply for this issue. The main window coordinator is responsible for initializing the main Caesura player window and handling the relationship between the left source list pane and the right collection pane. Because it does so much, it is definitely the meatiest of the coordinators in the application right now. I plan to split some of this functionality out into a separate object as soon as the next episode, but for now I do have to admit that it is a bit bloated. The main window coordinator has the following properties. Its parent coordinator, it has to conform to the main window spawner and player controller protocols. An optional reference to the main window controller. This is kept to have a reference to the window instantiated by this coordinator. Source list reloadable and collection reloadable are the two child view controllers, which conform to the reloadable protocol. More on this in a little bit. The library service, and then the state of the left source list pane, which is source list items as the list of sources, and collection type as an enum describing the focus collection. We've also got the state for the right collection pane. Tracks is the list of tracks, sort mode is the string identifier for the sort mode, keyword filter is the string for the keyword filter, and ascending is the boolean value of whether the right pane is sorted in ascending or descending order. Here's a peek into what flow management looks like for coordinators handling windows. The start method initializes the corresponding window controller manually by instantiating the window controller from the storyboard file, setting its coordinator property to the main window coordinator, and then calling the show window method on the window controller to present it to the screen. The end method, which prepares the coordinator for disposal, closes the window controller's belonging window, and then calls the parent coordinator's main window closed method so that any other cleanup can happen there. There's also a focus window method, which calls make key in order front on the window controller's window, which makes it the frontmost and focused window. Much like our root app coordinator, the main window coordinator provides a public facade to necessary playback-related actions existing on the parent controller. The main window coordinator is now what keeps track of both the focus collection and the tracks displayed in the collection view. We can now resolve things like changes in the focus collection in a much cleaner way than relying on Notification Center to bridge the gap between two different parts of the application. We also provide a rudimentary data source for both the source list and the collection's tracks, a front end to change the filters while triggering your collection refresh, as well as a playlist manipulation API. The goal of moving things into coordinators is to reduce the responsibilities of our window and view controllers to the bare minimum, that is, adapting information from other sources to be displayed in our views and responding to user actions. The main window controller was doing that already by virtue of the fact that it only really handled events from the Windows toolbar, as well as reflecting the currently playing track and its play pause status in the toolbar. None of that really changed. We just changed it so that it all happens through a coordinator instead of calling out directly to the collection player via the app delegate like we were before. The one big coordinator-related change in this class is the overriding of the show window method. This is the method that's called whenever we want to display a window controller's window, and we want to set it up such that the coordinators are available in that window's split view controller, which will then propagate it to its children as well. Main window view controller is a new subclass of NS split view controller that I made specifically to handle that propagation, and it has a coordinator property that we can hold on to that instance with. Then, in main window view controller's view will appear method, we get the two children view controllers from either side of the split view, the source list view controller on the left and the collection view controller on the right. We set those controllers' coordinator properties to the main window coordinator so that their calls to it will succeed. The coordinator also needs to be able to trigger reloads on the source list and collection view controls in a way that is not tightly coupled to the usage of NS outline view and NS table view. So I declared a reloadable protocol with a method called reload data. Both view controllers implement these protocols, so I can set them to the coordinator's source list reloadable and collection reloadable properties. Now that our coordinators have propagated down the chain, the view controllers can start doing their individual magic. Source list view controller still fundamentally does the same stuff it used to, but it does so in far fewer lines of code because it's relying on the coordinator to do that stuff for it now. You'll find that basically any delegate or data source that we are asked to implement, the same protocol methods are implemented here. They're just doing a lot less. Any logic that does not directly involve UI controls becomes a responsibility of the coordinator, and we just ask it for its result instead of doing the work inline like we used to. Almost every line of code in this controller is either asking the coordinator for information or directly manipulating a UI element with that information, as controllers should be in theory. Collection view controller is pretty much the same. Given how similar outline view data sources and delegates are to table view data sources and delegates, there is not much point in spending a ton of time explaining this one because it provides the same functionality as it used to in much less code and in a more reliable, less janky manner. That's precisely what I wanted to do with coordinators. Let's take a look at how the Preferences window has changed with the use of coordinators, starting with the implementation of the Preferences coordinator class. The initializer takes in an object conforming to the Preferences spawner protocol, which requires the implementation of both the navigate to Preferences and Preferences window closed methods. The coordinator has a few properties. Parent coordinator is the coordinator that spawned this child coordinator. Window controller is the Preferences window controller instance that our coordinator coordinates with. Path change handler is an object conforming to the path change handler protocol. Original path is the library path at the time that the window was initialized, and modified path is the property that stores the user modifiable library path for the window. The modified path property has a did set action. We call the path change handler's library path changed method, which lets that object do what it needs to display that new path in the user interface. We've got our trifecta of flow management methods here: start, end, focus window. Notably, in end, when we're calling out to our parent coordinator's preferences window closed method, we compare original path with modified path. If they're different, we trigger a soft reset of the application. Last, we've got our user actions here, which are pretty much copy-pasted versions of the old implementations of these methods from the old view controller. Like the main window controller, there's not much to see in Preferences window controller. It literally only handles the propagation of the coordinator property to its content view controller, which is an instance of Preferences view controller. And Preferences view controller has to be the most bare bones view controller in the whole application, as all of the methods it implements have only one line of code in their body, usually either reading or calling to the coordinator. It implements the path change handler protocol here at the bottom of the file, which simply sets the library path field string value property to the newly received path, or a blank string if it got nil as its argument. Our coordinator hierarchy has made it much easier for different parts of our application to talk to each other directly or indirectly, and because of this, a lot of misuses of the Notification Center API can be stripped away. Most of them, actually. As you can see in this file, which lists the custom Caesura notification types, only 3 custom notifications are left in the entire codebase. Caesura track changed for track changes, Caesura player started playing for when the player starts playback, and Caesura player stopped playing for when the player stops playback. These 3 notification types seem like much more reasonable use cases for the Notification Center API. It's nice to finally be able to stop misusing that API to work around structural issues with our codebase. Now that we've gone over the tour of how coordinators have really changed the codebase, I thought I'd show you the implementation of a feature we haven't been able to implement in a stable way prior to coordinators, a menu item that lets us reopen the main window if it was accidentally closed by the user. First, let's start by adding the Show Library Window menu item to the library menu in Interface Builder. Next, let's add a Show Main Window IBAction method on the AppDelegate class, which calls Navigate to Main Window on the root coordinator. Then let's wire up the menu item to this IBAction. That's literally it. That was a lot of work necessary to make that tiny seeming change possible. If we test here, you can see that I can close the window and reopen it just fine. Now this definitely works, but while preparing this episode, I discovered a bug with this feature, and hilariously, the bug makes it work better than it should. I forgot to ever add anything to the main window's controllers that would call the main window coordinator's end method when the window is closed. This means that we keep presenting the same instance of the window over and over instead of instantiating a new window from scratch and presenting that one. That's why stuff like the currently playing track, the play pause status, and the selected source and tracks are preserved across occurrences of the window being shown. My friend Rai messaged me one day and showed off this bug. If you had more than 10 tracks in an ordered playlist that was sorted by order, they would be listed 1, 10, 11, 12, 2, 3, 4, 5, etc. This sorting suggests that the order column was being sorted alphabetically instead of numerically. Turns out that the user order column on the ordered playlist track table was accidentally being stored as text instead of a numeric value. So let's add a second database migration to Caesura to fix the column. First, let's rename the user order column to user order old. Next, let's add a new user order column, this time being stored as an integer. Next, we want to copy the values from the user order old column into the user order column. This should succeed as all of our code up until now has only been storing integers in that column anyway. And now that the data has been properly copied over to the new column, we want to drop the user order old column altogether from the database. If we run it to test, you can see that the order column not only retained its values from the previous demo, but they're now being sorted accurately. It was a long journey, but I think that covers most of what I had to say about Caesura's adoption of coordinators. In the next episode, I'll be introducing the concept of read sessions, which should be the last major structural change before moving on to the second arc of the Caesura Guided Door series. See you then.